ordinary differential equation. So that topic I'll revise once again. So one problem also we'll solve in the variation of parameters. See the question, see the method. Variation of parameters. So see the method. So this method is useful only for the second order differential equation with the constant coefficients only, not for the more than two, only second order. So this rule is applicable only for this only. All a square by dx into dy by dx plus q into y is equal to capital R. So this is the second order differential equation. So with the constant coefficients, so where p and q are the constants here, and the capital R is any function of x. So this differential equations only we have to find a solution. So these are the steps we are following in the method of variation of parameters. So step one is, so first write the given differential equation into this standard form. So and next find the solution of that, means you have to find the complementary function. So find yc. So that yc is equal to yc is equal to c1 into u of x plus c2 into v of x. So after finding the complementary function, you assume c1 into u of x plus c2 into v of x. So and next is the to take the, next we have to find the particular integral. Generally we know how to find the general solution for the higher order differential equation. So complementary function plus particular integral. So here method of variation of, in the method of variation of parameters, finding a particular integral process is different. So finding the complementary function is the same, the previous one. So what are the process we followed? The same process you can follow and find out the complementary function. And YP is the different process here. So how can we find the YP? So YP is to take the YP is equal to A into U plus, that means A into U of X plus B into P of X. So here already we know what is U. So these are the U. This is the V. Okay, from the complementary function we are taking U of X and V of X. Okay, so then we have to find out the A and B. So how can we find out the A and B? So where A is equal to, the formula is, so minus integral V into R by U into dV by dx minus V into du by dx. So this denominator, we are saying it as a Wronskian. So B is equal to integral U into R by U into dV by dx minus V into du by dx into dx. So after getting the A and B values, you just substitute in this yp A into u of x plus b into v of x. So that is the yp of the given differential equation. And finally write the general solution. So general solution is y is equal to yc plus yp. So y is equal to yc plus yp is the general solution. So these are the steps we are following in the method of variation of parameters. So here in this denominator, particularly here, the denominator is, so this denominator we are calling it as a this denominator value. So this denominator is nothing but the Wronskian. So Wronskian. So Wronskian of u comma v. Wronskian of u comma v. So or simply you can write it as a w. So this denominator simply we are taking it as a Wronskian. That means if this determinant value is not equal to only, this integration exists. So Wronskian not equal to 0. If not equal to 0 only, this a and b values of the exist. Wronskian of u1 u comma v. So in different manner they will denote here in the denominator. W of u comma v is equal to determinant of u, v, u dash and v dash. We have to take the cross product. So this determinant only, here directly I have written the formula of the Wronskian in the denominator of a and b. So this is the process to find the variation of parameters. Now we will solve one problem on the variation of parameters. So remember the method here and now see the question. No class.
అయ్యింది. ఓకే ఇప్పుడు వచ్చింది ప్రాజెక్ట్.
దేంటిది ఇక్కడ? Okay, now see the question. Solve d square plus a square into y is equal to tan ax by method of variation of parameters. So now take the differential equation. In,
క్లాస్ సెకండ్ అవర్ ఉందా?
sir,
సెకండ్ అవర్ ఉందా?
third hour ఉంది sir, third, fourth. ఏంటి
వస్తాను చూడండి.
డిలీట్ చేసేసాను మొబైల్ మొత్తము క్యామ్స్. ఓకే, కింద ప్రమిళ మేడం అడగండి ఉంటాయి. So write the given differential equation. So given differential equation is d square plus a square into y is equal to tan ax. So this is a given differential equation. So see the given differential equation. Here the order is the second order differential equation. So the second order differential equation is then we have to use the variation of parameters. So in the problem clearly they mentioned the variation of parameters. By the method of variation of parameters, we have to solve this differential equation. See, if the second order differential equation is there, so if they didn't mention about by the method of variation of parameters, you use the method of variation of parameters and then solve the given differential equation. But the order of the differential equation must be two only. Must be two only. Okay. So for this differential equations, we have to find the general solution. General solution is a complementary function plus particular integral. First, see the complementary function. So yc we have to find. First we are finding the yc. So finding the yc. So first of all, what is f of d here? F of d is equal to d square plus a square. So we have to write the auxiliary equation. So auxiliary equation is f of m is equal to 0 here. F of m is equal to 0. Already we know f of d. So put substitute d by m here. M square plus a square is equal to 0. Then say what are the roots here? What are the roots?
0 plus or minus ai.
So here the roots are m square is equal to minus a square. So m is equal to plus or minus ai. So plus or minus ai. So we have to write the complementary function for the for complex number here. Here yc is equal to this you can write this as 0 plus or minus ai. This is alpha plus or minus I into beta or beta into I. So here alpha is equal to 0 and beta is equal to a. So then now write the complementary function e power alpha x e power 0x into c1 cos beta is here ax plus c2 sine beta is here the value is ax. So e power 0x is 1 c1 cos ax plus c2 sine ax. So again this one you can choose it as c1 into u of x plus c2 into v of x. So what are the method you are convenient, so you use that one only. Okay, so this is the c1 u of x plus c2 v of x. So where u of x is equal to cos ax, v of x is equal to sine ax. So u of x is equal to cos ax, v of x is equal to sine ax. So these are the u and v, and now we have to find the particular integral yp. So now to find the yp, so the formula of the yp is equal to a into u of x plus b into v of x. So a into u is cos ax plus b into sine ax. Can take this as a 1. And now we have to find out the values of a and b, where a is equal to minus integral v into r by u into dou v dv by dx minus v into du by dx into dx. So this value we have to find out. Before finding this value, so we have to find out the determinant of this of a and b. So determinant of a and b is the same values. So here u into dv by dx minus v into du by dx is equal to u is here cos x, u is cos x, v is sin ax. So u is cos ax into d by dx of v is sin ax minus v is sin ax d by dx of cos ax. So this is equal to cos ax into derivative of sin ax is a into cos ax minus sin ax into derivative of cos x is minus a sin ax. So this is equal to a into cos square ax minus minus is plus a into sin square ax. So take a common, a into cos square ax plus sin square ax. So this value is 1, a into 1 is a is the value of the denominator. And now we have to substitute this a value in a. So a is equal to minus integral. We know the value of the v here. V is sine ax. So substitute sine ax. And what is the capital R? Capital R is the right hand side. This is the capital R. So this is capital R. So capital R is tan ax. V is sine ax minus sine ax into r is the tan ax divided by a into dx. So minus 1 by a into sine ax into tan ax, you can write into the sine by cos. Sine ax by cos ax into dx. Ax into dx. Then now we have to find this integration value. Sin ax into sin ax is the sine square. So 1 by a integral sine square ax by cos ax into dx. So how can we do the integration? 1 by a into, you can write the sine square ax as 1 minus cos square ax by cos ax into dx. So sine square x plus cos square x is 1, we know already. Okay, so here you can write for the sine square ax as 1 minus cos square ax, since we have the denominator is a cos ax. So separate it, integral 1 by minus 1 by a integral 1 by cos ax dx minus integral cos square ax by cos ax into dx. So one time here is it's a cancel. So this is equal to minus of 1 by a into integration of 1 by cos ax is the secant ax. Secant ax dx minus integral cos ax dx. So this is equal to minus 1 by a into, so we know that already the value of integration secant ax. Integration of secant ax is log mod secant ax plus tan ax whole divided by a. Whole divided by a, this is the formula. So here we have the constant a is there. So this constant a we will get in the denominator. So this is the integration of the first one. So minus integral cos ax integration. So what is the integration of cos ax is sine ax by a. Sine ax by a is the integration of cos ax. And now multiply with 1 minus 1 by a. So first write the positive term. So positive term is sine ax by a square minus log of secant ax plus tan ax divided by a into a is a square. So this is the value of a. And now the finding the value of the b is equal to integral u into r divided by u into dv by dx minus v into du by dx into dx. So this is equal to integral u. So here the u is a cos ax into capital R is a tan ax divided by a into dx, divided by a into dx. So now, so this is equal to 1 by a integral cos ax into tan is sin ax by cos ax dx. So here cancel the cos ax and cos ax, cancel the cos ax. So this is equal to 1 by a integral sin ax dx. So this is equal to 1 by a into integration of sin ax is minus cos ax by a. Then again this value is minus cos ax by a square is the value of b. So this is the value of b. And now write the yp clearly here. So yp is equal to a into u of x. So what is the value of a here? A is this complete function. Sin ax by a square, sin ax by a square minus log secant ax plus tan ax by a into cos ax plus b. The b value is minus cos ax by a square into v of x. V of x is sin ax. So take the simplification here. So take the product with the cos ax. So sin ax into cos ax by a square minus cos ax into log secant ax plus tan ax by whole divided by, so here this is a square by a square, so the last term is minus sin ax into cos ax by a square. So this both the terms gets cancelled. So finally the yp is equal to minus cos ax into log secant ax plus tan ax divided by a square. This is the value of the yp. Therefore, the general solution is y is equal to yc plus yp. So where the y is equal to yc is c1 c1 cos ax plus c2 sin ax minus cos ax into log secant ax plus tan ax whole divided by a square. So this is the general solution of the given differential equation of order 2. So if it is the order 2, so use the variation of parameters. If not mentioned, also you can use the variation of parameters where the q of x, here the q of x previously in the previous problem we are writing it as a q of x. So here it is capital R. Here it is the capital R, that is the variation of parameters. Let's complete the ordinary differential equation. And now I'll explain the theory of matrices.
Excuse me, ma'am. Excuse me, ma'am.
Yes.
Ma'am, in variation of parameters, we have a second method also, no, ma'am, by taking W1, W2, and all.
Hmm. You are asking which one? W, right?
Yes, ma'am.
W is equal to what is the formula? So in
U,
that you are writing in terms of y's, right?
yes, ma'am. Ma'am, we can solve using any method, no, ma'am.
Any method you can solve. The same solution you will get. But what are the Ronskin formula? That Ronskin formula I have written directly in the denominators of A and B values.
Okay, ma'am.
Right? Method you are convenient, use that one and then solve. Okay.
Yes, ma'am.
Uh, how can we find inverse of a complex? So I didn't understand the question. So find the inverse of complex 2 by 2 matrix. So this topic is not in our syllabus. So finding the inverse of a matrix for complex matrices.
Ma'am, in non-exact, can you explain case 5? How to find particular integral?
Case 5 means dou n by dou x minus dou m by dou y divided by capital M, right?
No, ma'am, in finding particular integral where imaginary part, real part, and all that, ma'am.
Okay, in YP you are asking a question. Higher order differential equations,
Yes,
right? You are
ma'am.
asking, not non-exact.
Yes, ma'am. No, ma'am.
You're asking the fifth rule.
Yes, ma'am.
Okay. So I'll take one problem. You're asking the imaginary real part question you're asking. So that question I'll take and I'll explain that question.
Ma'am, only concept you say, ma'am.
Okay, only you want the concept, huh?
Yes, ma'am.
So if you explain the concept, it's not understand. So I'll take one problem. Just I'll solve only the YP part. Only few steps I'll write.
Okay, ma'am.
So that questions is not many in the textbook. Only one or two questions are there here. this problem we discussed in the class. So 8x square e power 2x into sine 2x. So the finding the yp is 1 by a square minus a 4d plus a 4 into 8x square e power 2x into sine 2x. So here the product of the three terms are there. So 8 into 1 by, so this d square minus 4d plus a 4 into, so first write the exponential e power 2x into x square sine 2x. So that formula also I'll write here. So this is 8 into, so first this is in the form of e power ax into v. So substitute d by d plus a. So e power 2x into 1 by d plus a is here d plus 2 whole square minus 4 into d plus 2 minus plus 4 into x square sine 2x. So this is equal to, so 8 e power 2x 1 by, so simplification, and the denominator we have to do the simplification, d square plus a 4 plus a 4d minus 4d minus 8 plus a 4 into x square sine 2x. So this formula I'll write here. Here minus 4d plus 4d gets cancelled. So plus a 4 and minus 8. Plus 4 is 8, minus 8 gets cancelled here. So 8 e power 2x into d square into x square sine 2x. Right? So this is in the form of x to the power m into v. X to the power m into v. So here 1 by f of d into x to the power m into v is equal to 1 by f of d into x to the power m. So where m is equal to 2, 3 and so on. If it is a more than 1, then you choose this formula. So v is here sine ax. V is here the sine ax or sine x, whatever it is the value of the a. So if it is the sine x is there, then how can we find out the particular integral here? So you can write this sine x as, so write or put sine x is equal to, or write, so you can write here, right, sine ax is equal to imaginary part of e power iax. Already we know the formula of e power iax is equal to cos ax plus I sin ax. I sin ax. So we are converting this sin ax, That means this completely function we are converting into the rule 4. So we need to convert into the rule 4. Then we are solving this one. Okay, this is the rule 4. We are converting into the rule 4. That's what we are writing sin ax as imaginary part of e power iax. So that here 1 by f of d into this means this function. That is, so I'm not writing this 8 e power 2x here. Okay, so this is equal to 1 by d square. I'm taking only this part, x square into, so imaginary part is, shortly I'm writing imaginary part ib of e power I 2x. So here the value of a is 2. Value of a is 2. Imaginary part of e power I 2x. So right before imaginary part. So imaginary part of 1 by d square into, first write the exponential term, e power I 2x into x square. Now this is in the form of e power ax into v. So here a is equal to 12. A is equal to 2a. And now I can substitute d by d plus a. That is a rule 4 we are using. E power I 2x into 1 by d plus 2i whole square. D plus 2i whole square into x square. X square is this. So now this is rule 3. Then use rule 3 and solve this. Use rule 3 and solve this. After solving this part completely, so in the place of the e power 2ix, so this one imaginary part of, so in the place of the e power 2ix, you write it as a cos 2x plus I sine 2x into, after solving this value you should mention here, write that function. Finally take the product of this factor, and finally you take the imaginary part only. Take only imaginary part, that is the solution of 8x square e power 2x into sine 2x. So if you are taking the real part of this, so that is 8x square e power 2x into cos 2x value, that is, this is a real part and this is a imaginary part. Okay.
Yeah.
So this way you have to solve in the rule 5.
Ma'am, planet is made by space, ma'am. I know.
Next is the theory of matrices. So in the theory of matrices, so first is the real and complex matrices. Real
Ma'am,
and complex matrices.
it's natural,
And the
ma'am.
second one is a rank.
It's
So a rank is in the rank. Here we have the two methods, or the echelon form and normal form. Gauss Jordan method, system of linear equations, a system of linear equations. In these systems, two forms are there: homogeneous, non-homogeneous.
Ma'am, I will ask a question to ma'am.
Homogeneous, non-homogeneous. And next is the last one is a Gauss elimination method.
Ma'am, I will ask you a question, ma'am.
So these are the 6 topics are there in this matrices. So which topic you want in this? You tell me in all these topics. So which one you want? So I think real and complex matrices are the only the definition, orthogonal matrices and the unitary matrix. So in that only. So we have to.
Ma'am, is unitary matrix means A conjugate whole transpose is equal to A inverse?
A into, so unitary A into A power theta is equal.
Ma'am, that is same as A power theta is equal to A inverse.
Yes, same.
Yes.
A inverse. We just
Ma'am, that's what I'm asking to how can we find inverse of a complex matrix?
I'm searching the question. Related complex matrices related problems are not here.
Ma'am, given in set 2 paper, CI1, set 2 paper.
ఓన్లీ
Hmm.
దెన్ అంతేనా?
ఎప్పుడు ఇది ఫ్రెష్ది కాదు కదా.
ఫ్రెష్దే ఇప్పుడు మేడం ఇచ్చింది. టోటల్ ఎక్స్పీరియన్స్ ఎంతనో అడిగి వేసుకుందాం అనేది. ఒకవేళ ఇంతే అయితే ఓకే అనేది చెప్తున్నాను.
30 minutes. Yes, you're asking the question in the mid examination, right? In the mid question paper,
Yes, ma'am.
you're asking the solution for that.
Yes, ma'am.
Okay. Okay, right. I'll see that question. Sir,
Last 5-6 years we developed focus chemistry.
so this is the question. The last last year internal question is this. So now see this solution of this. So we have to prove this matrix is a unitary matrix. So unitary matrix is A power theta is equal to identity matrix. So this one we have to solve. So take the given matrix A is equal to 1 by 2 into 1 plus I minus 1 plus I, 1 plus I into 1 minus I. So what are the process we are using to find the inverse? The same way you can also find out the inverse of this matrix also. So now I'll find out the A into A power theta product I am finding. So that product must be equal to the identity the matrix. So first here the A power theta. We know that what is a A power theta. A power theta is equal to A conjugate whole transpose or A transpose whole conjugate. So both are the same only we will get. So A transpose whole conjugate or A conjugate whole transpose. So that is a power theta. So now I am taking A power theta is equal to A transpose whole conjugate. Already we know that A. So first of all I'll write the A transpose. So A is equal to 1 by 2 into 1 plus I minus 1 plus I, 1 plus I, 1 minus I. This is the A. So from this, I'm writing A transpose. A transpose is equal to, you can write the 1 by 2 as the same. So you have to write the transpose of this matrix. So 1 plus I, 1 plus I. So minus 1 plus I, 1 minus I. 1 minus I, this is the A transpose. And now we have to write the conjugate of that matrix. So A transpose conjugate, sorry, A transpose whole conjugate is equal to A transpose whole conjugate is equal to 1 by 2 into the conjugate means we have to take the negative part of this imaginary. So 1 minus I will get. So next is also 1 minus I. Minus 1 minus I and 1 plus I. You have to change the symbol minus to plus before the imaginary number. So for the imaginary numbers only we have to change the symbol. So this is the conjugate. And now A. So this is also nothing but A power theta. A into A power theta is equal to A is here 1 by 2 into 1 plus I minus 1 plus I 1 plus I 1 minus I into 1 by 2 into 1 minus I 1 minus I 1 minus I minus 1 minus I 1 plus I. So this is equal to 1 by 2 into 1 by 2 is 1 by 4. And now you have to do the product of this matrix. So 1 by 2 into. So this product we have to find out. 1 plus I into 1 minus I minus of minus 1 plus I into minus 1 minus I. And next is 1 plus I into 1 minus I minus of minus 1 plus I into 1 plus I. And next is second row is 1 plus I into 1 minus I minus 1 minus I into minus 1 minus I. 1 plus I into 1 minus I minus of 1 minus I into 1 plus I. So here uh, we have to find the values of this. 1 plus I into 1 minus I. This is the positive and this is the negative, both are the cancel. So here we will get the 0. This is equal to 1 by 4 into 1 plus I into 1 minus I. So this is the form of A plus B into A minus B. A square minus B square. 1 minus I square minus of and this is this you can write this term as or directly take the product here. My 1 plus I minus I minus I square. So this cancel. Again I got here 1 minus I square. So next value we have to find out. So this is 1 minus I square. The second value is a minus. So product, next product, minus 1 plus I into 1 plus I. This is minus 1 plus I plus I plus I square. So here the value I got is 1 minus 1 plus 2I plus I square I got. And next is also 1 minus I square minus of
Ma'am, that one minus I we get the product.
this one, huh?
Previous, yes, that ma'am. That ma'am. Ma'am, product of minus 1 plus I and 1 plus I.
This one you are saying or this one?
Ma'am,
Which
that
one?
minus I and plus I will get
That's what
cancelled.
I'm saying. Minus I and plus I gets cancelled.
So which number you
Ma'am,
will
the element A12. A12.
this one.
Yes, ma'am.
This is not correct. So you are saying about this value, right?
Yes, ma'am.
What is that value you got?
Minus 1 plus I square.
Okay, minus 1 plus I square. Huh? Okay, I'll see. Let me see. Minus 1 plus I into 1 minus I. Minus 1 I got the 2i. You didn't get the 2a. Where I did mistake here? Uh, this one complete. One plus I into minus one plus I. Okay, this one is wait. Right, this is I plus 1 into I minus 1. So this is I think the I square minus 1, right?
Yes, ma'am.
Right. So I square minus 1, correct. And the next one? Next product is here 1 minus I into uh,
I
1
square
plus
minus 1, ma'am.
so this is minus 1 minus I plus I square. So I square minus 1, right? I
Yes, ma'am.
square minus 1. Right. Next, this is I got the these two terms I got the cancelled, right? Here I want this one is cancelled. I have cancelled here 1 minus I into 1 plus I.
మ్యామ్
Yes.
ఇక్కడ మ్యాట్రిక్ మల్టిప్లికేషన్స్ విల్ యాడ్ కదా మ్యామ్. అక్కడ మీరు మైనస్ పెట్టారు, యాడ్ చేస్తాం కదా మ్యామ్.
Right. So by mistake I have written here the minus plus this is. Right, correct. This is a plus only. Mm, so these two are not cancelled here. One plus I into one minus I plus one minus I into one plus I. Uh, this is the 2 times of 1 minus I square, I think. Square. 1 plus I into 1 minus I. 2 times of 1 minus I square. Mm. So this is equal to 1 by 4 into 1 minus I square plus 1 minus I square. So I square is minus 1 plus 1. Directly I am writing the value here. So this value is 1 plus 1 is
4, ma'am.
I got this is the value is 4 I got. And here minus I square plus 1 minus 1 cancelled 0. And here also minus I square plus 1 minus 1 0. So here also plus 1 2 into 2 is a 4 I got. So 1 by 4 into taking the 4 common 1 0 0 1. So 4 4 cancelled. This is equal to the identity matrix of order 2 by 2. So A power theta is equal to identity matrix. A power theta is equal to identity matrix. A pivot theta is equal to the identity matrix. So that is a problem for the unitary matrix. Okay, next you you try this another problem. Mm, show that A is equal to A plus IC minus B plus ID, B plus ID, A minus IC is unitary if A square plus B square plus C square plus D square is equal to 1. So you just to solve this, just for the practice only I am giving you, this is the question. Show that the A is equal to A plus IC minus B plus ID, B plus ID, A minus IC is unitary if A square plus B square plus C square plus D square is equal to 1. So I'm announcing the absentees for this today's class. So roll number 1, 2, 7, 10,